This is going to be a quick video on the Cadillac engine and rotor phasing and why the Cadillac has a little more trouble than most with this. This is an HEI distributor. Came out in '74. The first thing to note on Advance, you've got the Centrifugal Advance, and as it spins, it rotates. If you look, the contacts on the inside there, the little point to point, that's the trigger. So as the Advance fly out with centrifugal, the point rotates, and that's what causes it to advance in timing. Now the part I'm turning with my fingers is where the rotor mounts. So on centrifugal advance, as the advance happens down in the pickup, from the weights moving out, the rotor actually turns in order to keep the point of the rotor at the post that it's trying to fire. So no matter how much timing you get, it's always pointing where it was originally pointing. And so that works out real well. The problem is, and I've got a Mighty Vac hooked to this, as you increase on vacuum advance, the outside ring moves. Now, when the outside ring moves, you're not changing the position of the rotor. You're only changing the position of the pickup. So during this time, the rotor can start to move away from the post. Now, on a regular, like a Chevy, you don't have a big worry, partly because there's not a lot of vacuum. A good running Chevy might have 16 inches of vacuum. Well, a Caddy is going to be damn near 20. And so, as it advances, the rotor gets further and further away from the post that it's trying to go to. Now, normally this isn't a big problem. HEI has enough energy. It was designed to run that kind of vacuum, that kind of advance in a factory Cadillac back in the 70s when this came out. It was all designed to run together. But with Cadillac, there was a couple of things going on. One, with more vacuum, you're actually pulling that rotor further away than you would on most cars. Now, if you run a camshaft, lower vacuum, the motor's modified, you're probably not going to see a problem. But in a stock Cadillac with high vacuum, we tend to see a misfire, normally at idle, partly because the vacuum is hooked up on a lot of Cadillacs to manifold vacuum, and so you've got the full amount being pulled in by the vacuum can, and you get to the point where you get a misfire. Now, idle is the worst case place because it is the most stratified charge you have coming in, and it's the hardest to light. The throttle blade is closed, the vacuum is way up, the amount of air you're getting in there, air and fuel, is low. It tends to be low on a Cadillac anyway, but suddenly you need a lot of spark to do it. Well, the further this rotor gets away from the post, the more spark energy you're eating up. And so you can start getting misfires. And a lot of guys complain that you have a rough idle. Well, misfire is the rough part. And that can be caused by the distributor not getting enough spark to the plug to actually fire the mixture. Now, as they've aged, several things happen, and it makes this thing worse. One is the carburetor may not be giving you quite the factory spec mixture that it did back in the 70s when it was designed. So it could be harder to light. The other is these modules. Now, as they've aged, a lot of cars wind up replacing the HEI module. And you get just a cheapy, they were $7 to $14 over the years, basic replacement module. And you don't think about it, and they work great, and lots of Chevys ran them, and what's the big deal? Well, the problem is, to make these modules last, they actually reduced the amount of current that goes through the module. That protects the module from burning out, but it also reduces the amount of spark that you're going to get out of the HEI. The factory module from Delco was limited to about somewhere around 5 amps, I think. Some of these replacement ones are as low as 3 amps, and so it severely cuts down the spark. So suddenly we've got a big motor, we've got maybe the mixture not quite right, we've got a rotor slightly out of phase. All these things are eating up spark energy, and the module on top of that is not letting you produce as much energy as it would have even from the factory. Now, you've got several choices. There are aftermarket modules. This one is a Proform, and they are not current limited like the cheapy ones are. I think this was like a $25 module, and that'll help get more spark out of a factory HEI, and that's enough to make cure it, because as long as you have enough spark energy to get back to the post, you don't even notice a problem. It's when you don't have enough spark energy to get to the post and to fire the plug, suddenly you get a misfire, then you have a rough idle, and then you have a problem you're chasing. So this is one thing that can solve it, is just trying to increase the spark energy. That's one of the advantages of like running a MSD 6A box. Higher output energy, multi-spark, and so you may not notice an actual phasing problem in the distributor because you have enough energy, you're just going past it. Now, the other thing you can do is there are vacuum advances, again by Proform. I mean, this is just a basic adjustable vacuum advance can, nothing fancy. And what they do is they use an Allen wrench going down the throat where the vacuum hooks up to change the spring tension inside the vacuum advance. And you're saying, well, what's that going to do? Well, what that gains you is with your 20 inches, say, that the Cadillac has, you can increase the spring tension so you're not getting full advance out of the vacuum can. That will keep this from turning quite so far, and then the rotor stays within the range of pointing at the post on the cap like it's supposed to. This can fix it all by itself. Most of these vacuum cans, if you run full vacuum and you have, 20-something inches of vacuum, I mean, you can see on some of these as high as 30 degrees of advance out of the vacuum can. You don't really need all that, and that tries to move it around. So if you limit how much vacuum can pull in, you limit how much advance you see. So instead of seeing 30, it may only see 18 or 20. And that can be enough to solve the phasing problem to where you're not going to have trouble. It can also help you tune it and make it run a little better. So that is one option you can do, along with either increasing the spark energy or trying to go to a better module. In racing, a lot of times we eliminate the vacuum advance, and so in this one I've actually put a little bar in place of the vacuum advance with spots so that I can adjust the phasing from where the vacuum can was. This lets me make sure that the phasing is correct. Now, some of the worries when you get into racing, or if you run like an MSD box, is each piece of electronic you add in line delays the firing of the coil, and the rotor may be past the post because of that. So sometimes you've got to move this back and basically cause the trigger to happen sooner so that it happens when you want it at the post. That's phasing. If you run an MSD module that feeds or if you run an HEI module that feeds an MSD box with maybe a timing control unit, or you're running fuel injection where the computer is helping control some of the timing, all of those things have to process, and that causes a delay, and this rotor is still spinning the whole time, so it can go clear past the post, and it's having to fire all the way back to the post, and then you start getting misfires, and you're like, wait a minute, why is this thing not running right? Well, some of that is phasing, and so you've got to look at that. And when you look at that, one of the things, and I don't know if we can actually see this in the video, is if it's firing from the corner of the rotor, which means maybe it's coming back to a post that's back here. I've seen rotors that are only burnt on this corner or this corner, depending on which way it is, and it shows you that it's not centered on the post like it should be. Because this thing, as the vacuum changes, this thing is moving back and forth, changing its position. So for the most part, during most of your driving, and again, I'm hoping we can see this, if you look, the mark down in the thing is pretty much centered on the post. And that's what you're hoping to see. If you see it way over on the edge, or you see it, I've actually seen them all the way on the corner to where there wasn't even a mark on the post itself, that's a problem, and that needs to be addressed. So you got to figure out how you're going to fix it. The other thing you can do, if you don't want to do a module, or in addition to the module, is go to maybe a better coil. And that'll, again, up the spark energy. And that's not fixing the phasing, but it's letting you jump the gap from the rotor to the cap, get through the wire, and still have enough energy to fire the plug with a hot enough spark that it'll actually light the mixture. And that's another piece to get into, is the spark plug itself will, the gap determines how much energy it takes to fire that plug. Now in a Cadillac, a lot of times, they'll tell you in the instructions, or they'll tell you in the book, set it at 65 thousandths. Well, the problem is 65 thousandths takes a lot of energy. If you have that energy, it'll run fine. And that gives you a better chance of lighting mixture because there's more room in there. But a lot of times, especially on these older motors, you don't have the energy to jump 65. And that will start putting more and more wear on the cap itself. The spark energy has to go up, so then you start burning out posts, or you burn out this little center electrode, which on a factory setup is just carbon. Now, you can get better ones that aren't carbon, that won't burn out so easy, and deal with a higher voltage. But that's all stuff to worry about when you're trying to get it to fire. The problem is, if you really have a misfire, you are losing energy somewhere. It's not good enough to fire the plug like it's supposed to. And that could be mixture. That could be, phasing. That could be a bunch of things that you need to look at. But when it's rough, that's something you need to fix, because it's no fun to drive. You know, it doesn't seem like it idles right, and you can smooth it out. In the motor that I did, that was all factory, and I was just trying to make it run, I showed where I limited the vacuum advance. I put a little stop plate in here in order to stop how far this could go. And I decreased the amount of vacuum advance to 15 degrees. And that smoothed it out dramatically. I still had a little trouble because I think the carburetor mixture isn't quite right. And I added a better module to it, and that cleared it up. It was smooth as silk then at idle. And so both of those options are something that'll help you. But you need to look at the phasing and try and decide. Make sure it's firing in the center of that post. You know, take a look at the rotor and see if you can tell where it's firing from, where the arc mark is. And then if you need to fix it, try and decide which way you want to go to fix it. Okay? That's a quick down and dirty. Hopefully that gives you the information. If not, we'll try again.